Good afternoon. Good afternoon, everyone. Okay, just checking the sound here. Can you hear me okay? All right, great. I'm Luke Swetland, President and CEO of the Museum of Natural History and Sea Center, and I'm joined here on stage with Joe Black, who is from the Independent Living Resource Center. Joe will be providing sign language interpretation this afternoon. I'm also here with Olivia Uribe, who's with TransLPro, which is a local translation services firm, and she will be providing real-time Spanish language translation. So first, we're going to start with a little bit of housekeeping, and I'm going to invite Olivia, to do that. Sylvia is her mom, sorry. I'm going to invite Olivia to do that first because her Spanish is much better than mine. Olivia.
Buenas tardes, soy Luke Swetland, presidente y CEO del Museo de Historia Natural, y está también Joe Black, que va a dar interpretación en lengua de signos americanos. Y primero vamos a hablar sobre cosas que se tienen que discutir. Los baños están aquí afuera, cruzando la plaza. Si tienen un teléfono celular, por favor, póngalo en silencio y manténgalo cerca porque se va a utilizar pronto. También estamos transmitiendo estos eventos en vivo en YouTube y después va a estar en grabación. Si requieren audífonos para poder escuchar en español, van a estar disponibles aquí afuera. Y eso va a ser todo. Ahorita Luke va a dar la misma información en inglés. Muchas gracias.
All right, thank you, Olivia. She's going to go up to the booth so that she can start doing the translation. So let me run through that again. The restrooms are outside right across the plaza if you should need them. Please take out your cell phones, put them on silent mode, but wait, don't put them away because we're going to invite you to use them later in the program. I want to remind you all that we are live streaming today's event on YouTube. And in a couple of weeks, we'll have this recording available on our organizational websites, both a version in Spanish and a version in English with closed captions. This auditorium has an assisted listening device system. So if anybody needs a device in order to help with the sound, or if you'd rather hear today's presentation all in Spanish, please right outside, see Justin and Tristan, and they'll get you all wired up, okay? So the museum is pleased to be co-organizing this event with UC Santa Barbara Bren School of Environmental Science and Management, the Community Environmental Council, Santa Barbara Channel Keeper, and the Santa Barbara Foundation. We, the organizers, would like to thank Michelle Yee at Bank of America, the museum's Crystal Bianchi Fund, and Kimberly with Strategic Samurai for their generous financial and in-kind support that make today's program possible. So thank you to our sponsors. We had a lot of cats to herd to get to this moment, and two individuals did an extraordinary job of herding us, and that is the museum's Manager of Community Education Programs, Stephanie Coleman, and the Bren School's Director of Development, Beth Pitten-August. So thank you, Stephanie and Beth. Today's conversation is a follow-up to the Drought, Fire, and Flood Town Hall we, the partnering organizations, presented at the Granada Theater in 2018. The Thomas Fire and the January 9th debris flow had terrible impacts on our community. And I'd like to pause here and ask that we all join in a moment of silence to remember those we lost 2 years ago and to reaffirm our solidarity with those who are still recovering from those events. Thank you. Thank you for that. So the Thomas Fire and the Montecito debris flow also had impacts on our natural systems. Much has been done over the last 2 years to scientifically evaluate the nature and the severity of those impacts on our regional ecology. And this is what brings us here today. This is our window to share what has been learned and to consider what we have still to learn, so as to better inform our collective ability to balance ensuring community safety and protecting environmental health moving forward. So let's get after it. Let me tell you how we're going to run the program. We're going to start with a series of 4 flash talks. I'll introduce each of those speakers in turn. And then Dr. Stephen Gaines, the Dean of the Bren School, will moderate a panel discussion with 3 experts, and he'll introduce them at that portion of the program. Following that, Sigrid Wright, CEO of the Community Environmental Council, will offer her observations. Then we're going to bring our flash talkers back up and have an audience Q&A session. And the way we'll do that is you all have paper and pencils, so jot down your questions as we go along, and Justin and Tristan will collect those, and then we'll get them up to Steve, who is going to then pose the questions to our panelists, okay? And then we'll be wrapped up in just a couple of hours. So let's start with our first flash talker, Dr. Andrew Brooks, who's with UC Santa Barbara Marine Science Institute and the UC Natural Reserve. Dr. Brooks.
Thank you, Luke. I want to start things off today by having you all do an exercise in mental visualization. Imagine a dumpster, a simple dumpster. Now, if you're like me, you probably have a picture in your head right now of something that looks like that. Now I'm going to ask you to do something more difficult. I want you to imagine 19,500 dumpsters. It's a little harder, isn't it? If you were to line 19.5 dumpsters up end to end in a single line, that line would stretch for a distance of 22 miles, or roughly the distance from Montecito to Ventura. That's the number of dumpsters it would take to hold all of the material that flowed into the Carpinteria Salt Marsh following the debris flow of January 9th, 2018. Now, what were the impacts to the marsh? Well, you might imagine that that amount of material flowing into the marsh would have a large impact, and indeed it did. What I'm showing you right now is a photograph taken from a position indicated by this large red dot, looking in the direction of this large red arrow, essentially standing at the beach just outside of the Carpinteria Salt Marsh, looking toward the Santa Ynez Mountains, looking to the north. And what you see in this photograph is a typical marsh channel. And this is a photograph that was taken just prior to the debris flow. This photo was taken in November of 2017. Now, this is an image taken from the exact same spot, looking in the same direction, immediately following the debris flow. And you can see that this channel is now completely full of large woody debris and sediment that washed in from the burned foothills above the city of Carpinteria, down through Franklin and Santa Monica Creeks, and into the Carpinteria Salt Marsh. What impacts did this have to the marsh flora and fauna? Well, as a little bit of background before I tell you that, oops, lost my microphone. I'd like to tell you that the marsh is actually a hotspot of biodiversity here on the South Coast. The marsh is home to over 250 species of plants, many of which are endangered, such as the 3 I've shown here. Over 200 species of birds, and 150 species of marine fishes and invertebrates, right? So the diversity present in the Carpinteria Salt Marsh is incredible. What impacts did all of that debris have on that flora and fauna? Well, first, there was quite a bit of habitat loss. What you see in this photograph is a picture of a native Pacific oyster that cemented itself to the bottom of this rock. These are found in the bottoms of these channels within the marsh. And as you can imagine, species like this oyster, crabs, shrimp, clams were completely buried and suffocated by the large amounts of sediment that now choke these channels. The loss of those species caused disruptions to the marsh food web, as many of the species that were lost are important food items for species like this foraging shorebird. And finally, there was actually the introduction of a number of toxic compounds associated with the burned eucalyptus and chaparral material that washed into the marsh. We were faced with sort of an existential question right after the debris flow. What do we do? Do we clean everything up and try to restore the marsh back to its pre-debris flow conditions? Or do we step back, monitor the conditions to learn how these systems respond? What we chose to do was to step back, look, and learn. Specifically, we wanted to ask the question, how resilient are coastal wetlands to these types of disturbances? In other words, will the marsh recover? How fast will it recover? Are there things that speed up the process of recovery? And perhaps even more importantly, are there things that impede the process of recovery? What are we doing? Specifically, well, we're doing a lot of drone imagery work. And what I'm showing you here are two images taken before and after the debris flow. We can compare those two images, stitch them together, and form an image like the one shown here on the right. This is what we call a heat map. You may have seen these before. The different colors relate, in this case, to changes in the elevation that occurred in the salt marsh as a result of the debris flow. Things shown in red gained in elevation. In the case of the marsh channels, they got shallower. Things in blue increased in elevation, or in the case of the marsh channels, they got deeper. As you can see, these two channels became much shallower. If we compare the color of red you see here with the scale bar on the right, you'll see they became shallower by 1 to 1.5 meters. That's 3 to 4.5 feet of material that filled all of these channels. But a more subtler fact that we can take away from this image is that the entire image is sort of in a light pinkish hue. That means that the material that entered the salt marsh wasn't confined solely to these channels, but it actually spread out over the entire surface of the marsh. Now, how did the flora and fauna react? Well, we're still figuring that out. We're conducting surveys of the fishes, of the birds, of the marine invertebrates to see how they've responded to the changes in the physical conditions that resulted from the debris flow. What have we found so far? Well, some good news, some bad news. It depends really on whether or not you're a glass is half full or a glass is half empty sort of person. The glass is half full will be very encouraged by the fact that a channel that originally looked like this post-debris flow now looks like this. We meaning humans, did absolutely nothing to that channel. We did not dredge that material or carry the trees away. This is solely the action of the tides coming into and out of the marsh. For the glass is half empty person, however, I should point out that not all of the channels have recovered to this degree, and many are still in a very highly degraded situation. So what do we take from this? Well, my take on it is that the marsh is sort of at a tipping point. It's able to partially recover on its own, but not fully recover on its own. More impacts may push it more toward an inability to recover. Beneficial changes that we may make might push it back over into that ability to recover on its own. So as a take-home message, what I'd like to suggest to all of you is a list of action items. The first thing that we need to do is we need to preserve those wetlands that exist today, and even more importantly, we need to maintain the connectedness between those wetlands. A lot of the species that were extirpated by the debris flow, they're going to be recolonized by individuals of species that are found in other marshes up and down the coast. If those marshes go away, we no longer have a source for those species to recolonize from. And so we need to preserve the wetlands that we have, and we need to maintain that connectiveness between them. When and where possible, we need to restore wetlands that we've lost, right? That increases levels of connectivity and decreases the chances that some species that's only found in one or a few of these marshes might go extinct because of an episode like the debris flow that impacted Carpinteria Marsh. We need to improve the water quality of our local streams. Poor water quality is another stressor that the marsh ecosystem has to face. the more additional stressors we put on an ecosystem, the less able it is to respond to these large impacts, such as debris flows. And finally, we need to halt or slow the spread of non-native species. We actually saw quite a few species of non-native vegetation species enter the salt marsh along with all of that debris. And those species are slowly spreading out throughout the marsh, and now we're dealing with the impacts of the presence of those species in the marsh. So with that list of action items, I'd like to thank you all for your attention and thank you all for doing your part. Thank you.
All right, thanks, Dr. Brooks. Next, we'll go to the beach. And to help us do that, we have Mr. Brandon Steets, who's the senior principal with Geosyntech Consultants. Brandon?
All right, thanks everyone. Well, I'm here to talk about the microbial impacts from debris disposal at Goleta Beach. So a lot of you are probably aware that over 40,000 cubic yards, over 40,000, is that better? No. All right.
Is that working okay for you?
I'll use this. Okay. Over 40,000 cubic yards of material was placed at the beach following the debris disposal, the debris flow event. It's not the first time that volume of material has been placed at Goleta Beach. For beach nourishment periods in the past, similar volumes have been placed there. The material is first screened for large debris and tested for toxic chemicals before disposal, and the surf zone is tested for what's called fecal indicator bacteria during and following disposal. These are the same bacteria that are sampled across California beaches all summer long. This is what the disposal looked like from Goleta Beach. We see bulldozers placing the material into the surf zone. We see on the top right the smear of the sediment down current. On the bottom left, we see the turbidity in the surf zone, and on the bottom right, we see the signage from public health indicating that the beach is closed to recreational activity. So bacteria were elevated during disposal. This is not unlike any beach disposal period that you see during beach nourishment. What was different this time is that the fecal indicator bacteria remained elevated for months following disposal. This was unusual. The surf zone at Goleta Beach was then closed for 6 months following the disposal event. Health concerns were expressed by both the community and the elected officials, and I was involved in several of those discussions, explaining in plain language what was happening and why. We were then hired, Geosyntech was hired. We had previously done investigations at these beaches with university researchers, and we were hired to answer a series of questions. This is what the data looked like during the time that we were hired to answer questions. What you see here is Enterococcus, which is a fecal bacteria, shown as a rolling average over a year and a half. You can see what a normal winter looks like. A normal winter is about 10 times the standard. What we had here was 100 times that, and that's during the disposal. The disposal period shown in red. The mouth of Goleta Slough is in black, and you see the concentrations plummeting following the disposal. What we also see are the concentrations west and east of the disposal location. The current is towards the east, so the concentrations down current of the disposal location were higher for that extended period. Our job was to answer why this was happening and when would it be better. So we were hired to answer 3 questions. First, is it the sand on the beach that's causing what's happening in the water? That may seem self-evident, but we wanted to prove that with scientific lines of evidence. Second, what is the spatial extent of the elevated bacterial levels? We only had a few samples before we were brought on board. We wanted to understand, is it possible we were missing the biggest extent of those exceedances? And then third, is human waste present? This is the most important question, because if human waste is present, then the gastrointestinal illness risk to recreators and those exposed are going to be highest. The state standards are predicated on the assumption that human waste is present. If it's not present, then it would stand that illness risks are much lower than you would think based on the bacteria magnitudes. We were then asked to give recommendations based on those study results. This is what our sampling design looks like. So we had samples of sand and water, so orange is sand and blue is water, from the disposal location at Goleta Beach all the way to the pier. We figured this is going to be the most impacted zone, so we'll study that most intensely. This is the most technical slide that I have. So what this is showing is a plot of Enterococcus magnitudes per mass of suspended solids. So this is the samples in water. These are the samples in sand. The concentration magnitudes in water and sand were similar. This is one line of evidence that told us that the concentrations in water, which are causing the beach closure, are from a source that originates in the sand material. Secondly, the spatial pattern that's seen here is similar, this inverted U. This is showing that there's a concentration smear that's moving down current and is currently a little bit east of the disposal area in both water and sand. Two independent lines of evidence telling us the answer to the first question is, indeed, sand still remaining at the beach is causing a persistent exceedance in the water. Next is human waste present. What we're using here is we analyzed a human DNA marker that we and UCSB and other researchers all over the country use. It's a validated technique that is very conclusive and very sensitive. And what I'm showing is that at 4 samples per location, how many of those 4 samples in the form of a pie are either green, which is not detected, yellow, which is detected but not quantified. That's a very, very low level that this equipment is able to very sensitively detect. Or red, which means that it's quantified, above a level of about 1 to 10 copies per 100 milliliters. So the most we detected was around 100 copies per 100 mil. The published literature shows that it's over 1,000 copies per 100 milliliter. That's equivalent to the US EPA's tolerable illness risk, which is 30 illnesses per 1,000 recreators. That means 3% of recreators would take home a gastrointestinal illness. So this is an order of magnitude below that threshold in its worst sample. So what does that mean? It means, was human waste present in the material on the beach? Yes. Were the levels high enough to cause illness based on published literature? No. And is this roughly normal for a beach like this? The answer to that is yes. Coincidentally, working with UCSB researchers, we had been studying this and other beaches in Santa Barbara over the past several years, funded by the state. And we found that the beaches in Santa Barbara and this beach, not unlike any other beach in California, has an urban background level of human waste marker. And the levels are the same order of magnitude here. And the sources in that instance is bather shedding. In this case, you don't have bathers because the beaches are closed. So here it's the material that was disposed at the beach. So it's a low background level. So fortunately, after our study was done, the concentrations of indicator bacteria managed to return to below the state standard. What this allowed the county public health to do was to reopen the beach. So they had 2 bases to do that. One was bacteria levels had rebounded now down below the state standard. And 2, we had results now showing that there's not human waste present in the waters. So public health is protected and they can reopen the beach. What our results also allowed county public health to do is that when concentrations were to rebound periodically thereafter, they could post a warning rather than a closure. A closure is supposed to be done usually when there's a known sewage spill. Now we knew it's not the equivalent of a sewage spill, so they were able to issue warnings. So in conclusion, what did we learn? That bacteria levels were steadily improving and fell below the standards by the July 4th weekend. Second, the bacteria in the water were caused by the bacteria in the sand. There was no other source. Bacteria levels were highest near the disposal area and decreased down current. And based on the human marker results, there was no evidence of elevated human waste in the surf zone and therefore no elevated of human health risk. Our recommendations then were for future disposal activities to monitor bacteria as well as human markers and or human pathogen so that in the future we'll know directly if there's a public health risk during disposal. Interestingly, a year later, when the debris basins were cleared out during the next winter, the county heeded these recommendations. Surf zone and sand samples were collected before and during disposal and from the debris basins. They were analyzed for bacteria and human DNA. Enterococcus was predictably elevated in the surf zone during disposal, like any beach nourishment project. But then we found that no human markers were detected in the surf zone, sand, or debris basins, which is what you'd expect, because debris basins, as you all know, are located above the urban wildland fringe. So the material in them is made up of material from the open space wildland mountainous areas without opportunity for human contamination. So we were able to use our recommendations the following year to make conclusions to protect public health. And that's it. Thank you for your time.
All right, thank you, Brandon. Okay, we're going to take a little diverge here, and we're going to hear from Dr. Sarah Anderson, who's a professor and associate dean for diversity, equity, and inclusion at the Bren School. And she's going to tell us about some of the conversations she's been having with Montecito residents over the last 2 years. Dr. Anderson?
Thank you. Thank you. I didn't get the clicker. Can't do anything. All right. Maybe. There we go. So a couple of years ago at the Granada Theater, I told a story of a tale of two cities, a tale of our community right after the Thomas Fire and debris flows, and a tale of our community a couple of years later. And I was a little bit worried about what our community a couple of years later, when it had been some time since we'd experienced the debris flows and the Thomas Fire, might look like. I was worried about this because my research has shown that, my research has shown that as time since the debris flow or the fire goes by, the salience of that in our minds, the degree to which we're paying attention to it, falls off. And that's at the same time, in the case of wildfire, that risk is actually increasing as vegetation regrows. And so there's a mismatch between our attention and what's going on in the natural system. If you think about two cities, and we worked really hard to make them statistically equivalent and then looked across the western United States, what we found is that imagine one city that didn't have a wildfire and a second city that had a wildfire. What we found is that the second city, the city that had had a wildfire, was actually more likely to get government-sponsored fuels treatment on their landscape to try and reduce fire risk. And if you think about it, that city actually probably has lower fire risk than the city that didn't just have a fire, because this city had a big vegetation management, a big fire, and the other one didn't. Now, what made me worry is that after about 2 years, these cities become equivalent again, and we don't see that effect. So it's a very short-term effect, and that's what made me concerned that in a couple of years, we might not have reduced our risk. But in fact, after observing this community for the last couple of years, I think we actually have bent that risk curve down. We actually have taken some actions that seem to have reduced our risk in the long term. A little bit of evidence that we've done this comes from a survey that I did with some other researchers at UCSB of Montecito residents. If you lived in Montecito, you might have gotten a postcard and then a follow-up postcard and then a survey as we tried to get folks to respond. And more than 600 people sent us back those surveys. And one of the things that we learned from those surveys is that, in fact, Montecito residents are quite prepared. More than 40% of them have done wildfire renovations, so this might be things like screening vents or changing roofs. About 70% of them have a survival kit, and over 70% of them also have, it's gonna be exciting, an evacuation plan. And around 80% of them are subscribed to emergency alerts. Over 60% have defensible space around their house to avoid wildfire risk, and a smaller proportion have done some debris flow renovations. So we actually have a really prepared community now. And that has meant that we've bent this curve. As a social scientist, I wanted to understand why that was the case in this particular community. And so some of the answer, I think, also comes from that survey that we did. We actually have a really knowledgeable community. So when we think about debris flow knowledge in this community, more than 80% of people, or almost 80% of people, know the most likely scenario for a debris flow to occur. Probably all of you know. We need a wildfire and a really intense rainstorm. About 80% of people, over 80% of people, almost everyone know the number of houses that can be destroyed in a debris flow. And almost everyone knows the largest size of those boulders. They saw the boulders that came down. Around 80% know the fastest speed of a debris flow, and somewhat fewer know the largest that a debris flow can be. So we have a knowledgeable community. I think that's part of the explanation for why we have shifted that risk curve. But there's also a second explanation for why we've shifted the risk curve that comes out of some other research that I've done. So if we go back to these two communities, one that has not had a wildfire, one that has had a wildfire, I told you that the one that has a wildfire is more likely to have gotten a fuels management project. And it turns out that if that community, when we dig deeper into the data, is whiter, wealthier, more educated, they're actually even more likely. The gap is even bigger. So there's also a story here about inequality. And as a political scientist, I would call this political efficacy. We have a community that has a lot of political efficacy. That means this is a group of people who are knowledgeable, who have time, who have good networks, who know who to call in the case of an emergency or in following up on an emergency in government. And we can see evidence of this in the actions that have been undertaken. So in the debris flow nets that are above Montecito, in the debris basins, and even the proposed new debris basins. And in the kinds of organizations like the Bucket Brigade that have arisen in our community to solve the kinds of problems that we face. So we're a best case scenario in a way, and that also means I think that we're a bit of a cautionary tale. We are surrounded by communities who share our wildfire and debris flow risks. And I think it's imperative that we share our story so that those communities can learn from what we've done. So it's imperative that we share the story of what we've done after the debris flow. It's also imperative that we just continue to tell the story of the wildfire and debris flow. Other research that I've done with both legislators and with regular citizens shows that those who hear the story of what has happened, as opposed to a story of what might happen in their community, are much more likely to take action, much more likely to be prepared, much more likely to allocate resources to preparing. And so our story is powerful not just to us and us in this having this community conversation, but it's powerful to other folks. And so I challenge everyone in this room to take our story out beyond the walls of this conversation into our community and beyond our community to other communities that can learn from our tale of being a resilient community. Thank you.
Great. Thanks, Dr. Thanks, Dr. Anderson. So our final speaker is Mauricio Gomez, who's the director of South Coast Habitat Restoration, and his firm, along with a number of other organizations and government agencies, have been looking very closely at watershed recovery over the last 2 years. So let's hear what Mo and his team have found.
Thank you, and good afternoon. So the title of my talk this afternoon is Partnerships for Watershed Restoration and Community Resiliency. I've been working in stream restorations for about 15 plus years, and all those years it's been through partnerships. And that's one thing I want to highlight this afternoon with you all. what partnerships can do. A little bit about who we are. So we're a nonprofit organization that builds partnerships with restored degraded habitats. We work to protect, conserve, and restore the various habitats and biodiversity of the Santa Barbara and Ventura region. Most of our work focuses on the federally endangered steelhead trout, which there's a photograph up here on the top right. And a lot of that work is done as a result of removing stream migration barriers, which keep fish from working their way back up the creeks. And that's a photograph over here on the lower right of a small bridge in Carpinteria Creek. Keep that in mind. We'll come back to that in a few minutes. So we do that work in partnership with landowners, both private and government land ownership. We apply for grant funding. We work with consultants, get permits for projects. We oversee general contractors doing the work, and we perform community outreach. So there's a slide of where we do our work. So we're kind of spread out in our geographic area here in the Ventura River watershed. This is Carpinteria Creek. We're literally right here in Mission Creek. One of our first projects was actually just in the backyard here on the creek in Mission Creek, so I'm happy to be back here presenting today. And then we've done a ton of work in the Gaviota Coast, and we're starting to do some work in the Gaviota Creek itself, as well as back in the backcountry with the Forest Service. So as you can see, we've done work in a lot of different areas, and we've gotten to know a lot of the creek systems around this region pretty well. And so I'm going to go through a few slides of one of the projects that we did a couple years back to show a little bit of example of what gives us the experience of doing the work that we've done. So this is the before photograph of a small bridge. It was about 25 feet wide, and there was about 100 feet of concrete in the stream channel. This slide shows after us doing a lot of work on the back end with grant funding and permitting and contractors in partnership with the landowner to start removing that barrier to migration and make this thing go away. So here is the new stream channel that we've restored with placing boulders as well as vegetation in there. You can see that old bridge that was there is gone. And we're starting to build a new bridge at that location, which is more than double in width, and it has more capacity. And here's the new bridge going in. You can also see some of the vegetation starting to take hold that we planted at that site. This is always a fun day for our work when the bridge actually gets delivered and it fits. It's a pretty important thing. And this photograph was taken right after the project was completed. So a little bit of rain that year we got. Bridge looks very nice. We got a lot of willow poles starting to take hold and vegetation that we planted on the creek banks, native plants and whatnot. And so that's a little bit of a kind of summary of some of the work that we've done. And then this is what it looked like about a year after that. So you can see a lot of new growth, a lot of willows and sycamores, cottonwoods that we planted in there looking really healthy and looking nice. Creek's flowing really well. I wanted to jump in there to see if there was a fish in there, but didn't want to get wet that day. So taking us over to the fire now. This is the perimeter of the fire. And we've did a little analysis in the office of looking at the different watersheds themselves. So Montecito, San Isidro, Carpinteria, Rincon, Ventura. And over here on the top right, this is the area of the watersheds that burned. So you can see a lot of these watersheds burned. There was a lot of destruction that happened, a lot of impacts to our creeks. So the next few slides are going to show some of these impacts to the projects that we did work in. And this is back to that one slide that we just showed you, the photograph over here of that bridge that was complete. And after the debris flow, this is what the creek looked like. Most of the vegetation was stripped out of the ground. There was a pile of debris that was lodged up in the creek channel itself on the upside of the bridge, but the bridge withstood the location that was placed. The engineers did the work that they needed to get done, and it was reviewed by the different agencies that need to review it, and it withstood the debris flow at that location. And keep in mind, there was also a debris flow in Carpinteria, not to the extent of what happened in Montecito, however. Just up the creek from that location is a different bridge that we installed as well as part of our fish passage projects. This is looking up the creek, this is looking down the creek. And this project is located immediately downstream of one of the county debris basins. And that county debris basin was able to stop all the large boulders and kept them from coming down the creek. What did come over the creek, though, in that location is all these floating logs. And as you can see, this bridge effectively blocked a lot of those logs from going down there. However, many did make it down to the creek as well and down to the beaches. But some of the impacts that we saw as a result of this is there's a lot of debris in the stream channels, of course, related to rocks and boulders, as well as logs. We had loss of riparian trees, which provided cover for a lot of the species that were in the creek channel there, as well as a lot of sedimentation and scouring impacts to the stream channel. That's something that we've observed a lot in the stream channels, that the creeks look nothing like they used to look like when we used to hike these creeks. So a couple slides of that. There we go. Oh, I apologize. So one of the things that happened as a result of this impact, we, with a bunch of colleagues, ended up working on a project to figure out what can we do as a community to better improve ourselves and be ready for something like this. So over the course of 4 meetings in 2017, with over 150 different participants from different agencies and nonprofits, we created the Fire and Flow Forums. And we created this strategic planning document that ended up going through a strategic planning process that uses the acronym SMART, which is Smart, Measurable, Attainable, Relevant, and Timely. Through that process, the group identified 5 priority areas that we really wanted to think about and focus on as we move forward. The 5 areas included infrastructure and restoration, community science and outreach, research and monitoring, future management, preparedness and resiliency, as well as coordination and prioritization. With those 5 focus areas, we had 17 goals and 100 objectives that we've been now using toward our efforts to try and improve our efforts toward creek restoration and trying to coexist with human nature, as well as infrastructure that we have in our community. And all that was done through partnerships. And so this is just a slide that I put together with as many partners as I could throw on here. And all these individuals, all these organizations, agencies are ones that are responsible in some way, shape, or form with something related to the creek or emergency event, such as the fire and debris flow, and that have been supporting events like this. There's been many different examples in our community. Up on the top right over here, we have an example of one of the ring nets that was installed in Montecito by the Partnership for Resilient Communities. We have on the bottom right over here a photograph of the Cold Springs debris basin, which in the near future there's plans to try and work on that, and Tom Fairham is here and probably be talking a little bit about that, to try and partner with the community, figure out how to make habitat and people coexist in a way that's going to be helpful for everybody. And so, in closing, recovery is occurring, but it takes time. And there's recovery taking place. And these 2 photographs were in the Newshark article from, I think that came out a couple days ago, photographs by Ray Ford. And these are at the Cold Springs confluence of the East and West Fork. You can see on the top right is the photograph that he posted right after the event happened. And there's hardly any green in this area. You can still see burned trees. On the lower right, this photograph was recently taken, and you can see growth. It's coming back. The trail's back. The trails groups have been doing an amazing work to try and get the community back out to where we really want to get to. The roads have been improved. New bridges have been built by Caltrans as well as the county. The creeks are getting restored in different areas as well. But sometimes it requires us to get involved, and other times things happen on their own. And so in closing, it's important for us to have a strategic plan in place for how to recover and how to respond for recovery in order for us to come out of these things with our head up and see what we can do better the next time. So with that, thank you very much.
All right, thank you, Mo. Thank you to all of our Flash Talk speakers. I think there's a lot of groundwork now that Dr. Gaines can build on with the panelists to kind of have a robust discussion. So we're going to get that set up. I think you guys are coming up. And in the meantime, I think we need another slide up. Does that have what? Oh, no. No? Help? Ah, okay. Now, we had you keep your cell phones out. We're going to invite everyone to use your cell phone and go to polev.com, enter Steve G 122, and we're going to be asking some questions that we can have an interactive conversation with you. So that's really cool. And for anybody that's watching on the live stream, you can also participate in the Poll EV even though you're not in the room. So let's get set up, and I'm going to turn it over to Dr. Steve Gaines.
Thank you, Luke. And those were a fantastic 4 set of talks to kick us off. And so we're going to bring up our 3 panelists, and this is going to kick off the rest of the meeting where we're actually going to be having a more engaged conversation. And so this is part of the reason is we want to be able to get you engaged for a whole variety of reasons to help the discussion that we're going to have here with the panelists actually be more relevant to the kinds of interests you have, but also for us to be able to gauge a variety of things that you have done and you're thinking about and so on and so forth. So let's go to the first question so we can just kind of practice here before we get into things that are really important. Okay, the next slide. There we go. Okay, so this should show up on your phone as a question. Let's. Password for the guest Wi-Fi is mammoths, all lowercase. Mammoths with an S. Oh, excellent. So we're getting some response. Guest. Is it just called guest?
It's called guest.
Should be just guest. Okay. Let's try the next one. It's also an icebreaker question, a little bit, of a different form. We're going to try a variety of different questions as we get this going. Can I have the next slide, please? This thing's not working. Okay, so this one you get to type in a word that you think describes your community. And excellent. That's a good one to see. And so the size of the word here is going to reflect the number of people that put the same word in. Good to see resilient playing such a prominent role here. Okay, so hopefully we have enough of the audience being connected that we can go on to dealing with some of the questions that are going to tie into more with what we're going to do. And so I really want to focus on for this next section, talking with our panelists on a variety of issues related to community resilience, which I think rests on our ability to anticipate, prepare for, and adequately respond to future events, both extreme like the two events that we've been talking about here today, but also chronic changes that are going to be potentially happening from climate impacts and other things along those lines. And so what we've done is assembled a panel of people that represent three different sectors where this question is really relevant. And these are regulatory agencies, environmental NGOs, and the ocean sector. And so I will introduce our speakers to you here in just a minute, but I want to set them up with the next question, which is going to help us start getting a sense of your perception on some of these issues. So how well do you think we have already learned from the fire and debris flow and improved our resiliency in the last 2 years? And so you can click in this space as to where, and we seem to have a somewhat bimodal response here with some people think we're doing pretty well and others think we have a long way to go. That's great. Okay, let's go one more. Next slide. What do you hope to gain from today's discussion? This is a selfish question on my part to know if I need to rewrite my questions to the panelists really fast. And what'll be different here is that you can write out sentences like this, and if somebody puts up an idea that you like, you can just click on that from the bottom of the list and add to it or subtract to it in terms of representing the importance that you think we want to see. It's great. Well, our flash talks have already done a lot in some of the areas that are at the top here, updating information, sharing the knowledge we've gained already, new insights, things along those lines. Good. I don't have to rewrite my questions. So let me introduce our panelists. So starting on your left and moving across the group here, we have first Kim Selko, who's a researcher at the National Center for Ecological Analysis and Synthesis, NCES, which is a UCSB scientific synthesis center that really is a world leader in environmental research. But Kim has also been a community leader on fishery sustainability, serving on a variety of different fishing organizations and associations, and leading a community-supported fishery program called Get Hooked. Next to Kim is Ben Pitterly. Ben is the Science and Policy Director for Santa Barbara Channel Keeper and has a background in a variety of issues related to watersheds. And so he's here representing the NGO community. And then third, we have Tom Fayaram, who's the Deputy Public Works Director of the Santa Barbara County. He's been there for more than 30 years and has the potential of then providing some real insights in terms of thinking about some of these climate impacts on the regulatory and management institutions within our systems here. So let's start with two questions that are going to set us up for my comments with Tom. The first one is, what preparedness actions did you individually take before the fire and debris flow to mitigate impacts to the community? What kinds of actions had you already taken before these events actually even occurred?
You want me to go ahead, or is this?
Oh no, let's get their answers to these two questions, and then I'll say why I asked these to them to set you up, Tom. So far, none is winning with the highest frequency of, well, it's tied with emergency pack. Okay. This is what I suspected. A relatively small number of actions taken before these kinds of activities. Okay, let's go to the next slide. And another motivation for asking these two questions, I'm trying to get some more data for Sarah for her next paper in terms of looking at how people have done these things. So now it's, what actions have you taken since the events to help improve community resilience to future events? And we've put a few general choices on here so we can look at individual activity and responses that have happened. So, updated emergency plans, pretty equal distribution for the others, donating time and money, taking part in policy change. So a lot more activity than in the first one. And I think this is what I want to set up. The question is really the fact that these kinds of events do provide not only an opportunity for action, but they provide an opportunity for serious learning. And a lot of that you've already heard about with these flash talks. And so, Tom, I want to set this up to you from the standpoint of that regulatory agencies face some really tough challenges with these kinds of really extreme events. And because they're irregular and way out of the ordinary. And our regulatory institutions and management institutions are really framed typically around coming up with rules and regulations and approaches that make sense for the normal kinds of things we're dealing with on a day-to-day basis. So what have we learned from the fire and debris flow in terms of driving resilience in our regulatory institutions?
Well, I think, one of the things we have to keep in mind on the debris flow, it was a rather extreme event. And so one of the questions that have been going through, I think, a lot of people's minds are, what is the this is standard of care for what we prepare for. Now, in the case of the Thomas Fire and then the 190 debris flow, we had several debris basins that were in place, and those are regulated by the California Department of Fish and Wildlife and the Corps of Engineers. You have to get permits to do that type of work, and all those permits were in place. And we were able to do all the work that we needed to do before the fire. And keep in mind that that was a very narrow window. The fire was actually put out by the storm on 1/9, and it was still burning at that point in time. So to one extent, the process in terms of getting regulatory permits to do the work we needed to do beforehand worked because they were in place. They were in place that if there was a fire, our debris basin maintenance plan established that in a non-fire, everything kind of status quo watershed, and we operate our systems in this manner. In a fire, we know that things are drastically different. We have to do things different. So that's what we took action to clean out our debris basins. Little disappointed to see on the first question that people said nothing was done, and that's absolutely nothing could be further from the truth. There was a lot of work that was done prior to that. However, post-debris flow and post-action, the regulatory climate starts to get a little more complicated. We saw a lot of information about the work that was done at the beaches and the extremely difficult job of managing the amount of material that comes off of a watershed when it's in its burned state. And where does this go? Do we starve our beaches of this material, or do we try to reintroduce it back into the natural system it came from? Do we haul it 70 miles away, and is that the right thing to do? And so we have and then also having an ability to have a location where we can manage sediment that comes out and be able to sort things and accordingly be able to put them in a proper place, which could include contractors' use on projects, ocean beach nourishment, and then maybe ultimate disposal for others. And we have to work on that yet. So I don't know if I hit all the points that you were expecting from that.
Yeah, no, that was great. And, it strikes me, so you've given us two examples, one in the case of fire, where it sounds like we had enough of an anticipation of the scope of the activities that were needed to respond effectively to that we actually were able to take pretty effective action. Whereas in the case of the debris flow, it was a much more rare event and so on and so forth. So it raises the question, what are the lessons you've learned from this that you think would be relevant more broadly, thinking about other kinds of regulatory agencies in terms of how they need to be thinking in a forward manner about future kinds of rare events that we might be experiencing on a much more frequent basis? What are the lessons learned that can be transferred to other agencies and things like that?
Well, certainly the lesson learned is that we have not really solved the problem of how we're going to be able to respond in a post-event. It could be a debris flow, it could be a debris-laden flood, it could be a number of things. We have more work to do in terms of being able to come up with a plan for how we handle the material. And again, keep in mind that this was an extreme event, but it was also an extreme event in a narrower slice of the South Coast, whereas if many of us may remember in 1995, we actually moved more material in 1995 than we did in the debris flow because it was across the entire South Coast, and so it had a much broader area. And that also included material going to the beaches and sorting facilities and others as well. But we definitely, one of the big lessons learned, we have to be better able to deal with the material that comes down and be able to stage it, source it, and then ultimately have a final resting place. And in many cases, that makes a lot of sense that's the beaches. Goleta Beach, we have a rock wall because we have a deficit of sediment. And so a lot of people have talked to me are that what's happened with our debris basins is that we're starving our beaches of the sediment because we trap it and then we truck it and haul it off somewhere, and that's not a good thing either. And then I'd also just close with one thing we've learned that we're trying to implement moving forward. I think Mo mentioned the Gubernador debris basin, which showed the example of how we were able to stop the rocks there. That was a debris basin that actually was notched and made fish passable, and it also allowed the natural sediments to pass through. We're taking that lesson learned and the fact that it worked. It was a pilot project, and we're now applying that to many of the other debris basins across the South Coast, so that one, they do a better job of stopping the large rocks, and that two, they will keep the sediment in the natural system and let it get to the ocean where they need to go.
Fantastic. So I mean, you've hinted on this a little bit, that there are still challenges to resolve. Can you give us an example of what you think is the biggest challenge that's still unsolved from the standpoint of the types of issues you're dealing with, and what is it going to take to answer that kind of a question? How do we actually look forward and think about solving some of these big remaining challenges?
Well, I think when I look at just from our operational actions after a flood or a debris flow, moving material, we really need a place to be able to take this material. And I would submit that Buellton and Ventura County is not the answer to that. But we need to have this location where we can sort the material out and repurpose it instead of hauling it 80 miles away and basically throwing it away and then depriving the beaches of that sediment. And so that's probably the biggest debris management. And by the way, that doesn't just go for public agencies. Debris management, a lot of people in Montecito were affected by that. They had a lot of debris, rocks and sediment put on their property, and the county doesn't remove that off private property, so they have to deal with that. And so how do we deal with that and helping them in the case of a fire or an earthquake, and they have a lot of material that might be available, how do we handle that? So that's a challenge that we have moving forward that we need to work on.
Fantastic. Okay, let's move on and set up something for Ben next. So let's go to the next slide. Okay, so this is a statement, and we're asking for your response to this statement in terms of whether you think it's completely true or you disagree completely. We can effectively manage ever-increasing threats of climate change through traditional low-tech solutions: stream bank and coastal armoring, dams, dredging, etc. Pretty clear response from the audience on this, that's not going to be enough as we see this. Okay, so Ben, from the standpoint of another sector here, Santa Barbara has a rich set of environmental NGOs that have played very active roles in solving a whole variety of environmental challenges and have actually been national and global leaders in a lot of different kinds of problems. So I wonder if you could start off by kind of giving us, from a similar kind of thing, from the NGO perspective, what have we learned from the response to this kind of a disaster?
Yeah, thanks, Steve. Well, I think, for one, it's pleasing to see that the focus of this discussion, and I think it was illustrated by some of the live feedback that we received, was that we're focused on the word resiliency, and this is a discussion that's about looking forward. From the environmental NGO perspective, of course, I could speak to environmental resiliency looking forward. I know in the immediate aftermath of the debris flow, there was a lot of alarm and concern at that time about environmental impacts. And that was a different situation. It was an emergency, and things were done as our local agencies were literally still involved in search and rescue operations. And so I do think that the discussion should be what do we do moving forward, and in terms of watershed protection, I suppose I would be most familiar with, we're talking about a lot of issues here, fire management, but I would be most familiar with flood control. And I can say that the issue of flood control it is one of the most challenging issues that we deal with from an environmental NGO perspective. I think most people in this room would agree that our local agencies, local governments have an obligation or responsibility to protect our homes, our infrastructure, certainly protect lives. I think also most people in this room would agree that our local agencies have an obligation to minimize impacts to the environment and eliminate impacts to the environment if possible. And flood control, it's one of these issues that it touches upon, you know, both sides of that equation. And a lot of people, when we're dealing with watershed impacts, we focus a lot on stormwater runoff and pollution and these types of things. But a truth is that a lot of the historic, the legacy of kind of impact to our watersheds occurred because we historically developed in floodplains. And when we did that, then there was an obligation to go in and protect those homes. And one of the ways that we've done that is by altering our watersheds. So we went in and we channelized creeks, made them straight, right, to keep them from meandering. And when you do that, you accelerate the water's moving faster, and now you have more erosion issues, right? So then we armor stream banks to protect the stream banks, and now you have permanent or semi-permanent stream bank armoring that causes ecosystem impacts. In the worst cases, we've completely channelized our creeks. We've turned them into concrete channels, which of course destroys the ecosystem. And I would say even has a more insidious effect in that it causes the community to not care about these places anymore because there's nothing there anymore. It's just a concrete channel. There's no more recreation. There's no more opportunity for access. And these have long-term impacts to the community that I think we still are living with. In this discussion, I think the issue of debris basins and management and sediment management, and I do want to acknowledge here that I do think Tom has one of the hardest jobs of any of us in this room. I think, you know, the job that he's tasked with to protect, you know, to protect us while also navigating a very challenging regulatory environment. I just want to acknowledge that people working for the county that do this work, you know, are trying to do the right thing and the best that they can. That said, it is a challenge now. We have all this sediment accumulating in debris basins. There may be benefits by trucking that material to the beaches. Some of that material probably would have been there. There are also impacts. There are water quality impacts. There are impacts of the dredging, impacts of trucking. And I think that it's good that we're having these discussions because there is, I believe, still room for improvement. And those are things that I think the county's still working on. In terms of how we learn lessons, you know, it would be the impacts that these activities cause. I think it would be a less bitter pill to swallow if I had confidence that we weren't necessarily repeating some of the same mistakes. And you know, one issue that comes to mind for me is that, you know, we say that we don't want to, it doesn't make sense to spend gas and make greenhouse gas emissions, you know, hauling material, whether it's to Ventura County or whether it's to our beaches, excavating, hauling, dumping. But then at the same time, we're proposing to build new debris basins, right? There's a new one proposed at Randall Road, and maybe this one is gonna be an improvement on the old one. It's gonna catch more of the good stuff and less of the bad stuff. That said, you know, I think in the face of climate change and understanding that some of these threats, fires, floods, will become more frequent, that we're less able to control these things, it's an important question to ask. At what point do we leave these systems alone?
So that seems to be a good setup that's right in line with the response from the audience, that we need some new innovative solutions. And I wonder if you could say a little bit about, you know, how do we move in that direction? How do we actually drive innovations if the solutions that we have today work okay, sometimes have unintended consequences, but are not adequate in terms of thinking about long-term solutions to these kinds of challenges?
my job's a lot easier than Tom's, and that I get to, I don't have all the solutions, and it's easy for me to point out all the problems. That said, I think we can answer that question in the short term and in the long term. I think in the short term, when we're talking about sediment disposal, debris management, I think what the county is doing now to look for areas to do more sorting is a really important step. One of the primary water quality issues with the material that gets placed on the beaches is that it's filled up with too many fine particles as opposed to sand, which is what we want on our beaches. And there's an issue with not having space or capacity to actually sort that material out. I think also when we're talking about perhaps expanding the use of this material from debris basins to put on beaches, from our marshes, maybe even to put on beaches. I do think that there's still room to talk about timing. When does that occur? How long does it occur? How long does that activity occur? How much are we placing? And is there a way, and how are we doing it? And is there a combination of those, factors that could at least minimize the impacts to the environment? And then in the long term, I'll make this quick, but I really don't know. Do we think that we can manage sea level rise, fires, flooding with bulldozers, seawalls, and concrete? At some point, does the community need to face up to the fact that we're living in places that are in the path of nature, and that we can't control nature? There's nothing that the county could have done to prevent what happened during that debris flow. There's nothing. And are the things that we're going to think about to move forward to increase our protection, the increment of protection compared to the increment of environmental impact? There's a balance there. There's a fine line there where, as a community, we need to start talking about getting out of the way, and I think that's a conversation that really still needs to take place.
Mm-hmm, mm-hmm. That's great thoughts. Okay, let's move on to set up Kim to the next slide. So how much did the fire and debris flow affect our offshore ocean ecosystems? So we heard some great presentations that showed some of the coastal impacts right at the beach. How did this translate into activities offshore? Okay, so there's the perception that there's still large and lasting impacts going on in the coastal ocean. So Kim, given your connections with both the ocean science community as well as the fisheries community, what's been the evidence that you've seen so far in terms of the broader impacts into the channel?
Thanks, Steve. First, I have to say I'm having flashbacks to my PhD defense. Steve was my advisor. But I know I'm not, there's no PhD at stake here, but something much more important. I think that the reality is that we only have anecdotal information, unfortunately, about these lasting impacts, and even the acute impacts at the time of the event. I've talked to the fishing community as much as I can, and most people have said the fishermen in our community had no impact, with the exception of the folks that really depend on the coastal kelp forests, which are a very important ecosystem and very beloved by our community. To the south, from Montecito to the south, or the northern Ventura border, the kelp forest declined rapidly after the debris flow, and the folks that harvest the kelp on the kelp cutter boat you may have seen in the harbor And a lot of that kelp goes to feed our abalone at our abalone farm at Dos Pueblos Ranch. They were not able to work at those beds anymore. They take about 1.5 feet off the surface of kelp, and recall that kelp is the fastest growing plant on the planet, and this is not a high impact activity. But those kelp forests were really starting to fade after the debris flow, and so they moved their operations to the north, actually off of Hollister Ranch area. And they have not gone back to that area because they feel that the kelp forests still have not recovered well. And they attribute that to the sedimentation that occurred that smothered the roots, the holdfasts of the kelp, and it has not allowed the kelp to kind of recolonize as it gets ripped out by winter storms. So that's really unfortunate. It's all anecdotal. There's certainly only a correlation there about the timing. And another thing that I heard just today, picking up some oysters for our Get Hooked customers down at the dock today from Bernard Friedman at Hope Ranch. He's got a mussel and oyster growing facility offshore, and he said that pretty much starting the summer after the debris flow, he started to experience larger rates of die-off from his mussels than he's seen before, and he has not been able to explain that. And he, again, that's even a weaker correlation probably, and there's many things going on in the channel. So I think that what happens is that this is a very acute event, and you layer that on top of a chronic stress, many chronic stressors that our channel is experiencing, such as eutrophication from sewage and other non-point source pollution, and also warming. Our channel has warmed by 2 degrees in the last few years. There was a warm blob experience that happened along the entire West Coast several years ago, where we had extremely hot temperatures. And when that receded and those temperatures went down again and the blob dissipated, the temperature in the channel remained at a slightly higher temperature than it's ever been before that. So it didn't kind of go up and down, it went up and then it stayed. And so the channel's already experiencing a lot of stress. And this is the type of event that it becomes very hard to tease it out because you're not expecting an immediate impact. It'll take some time for that sedimentation to affect the habitat.
So that was perfect segue to what I wanted to talk about next, which is that even if there aren't strong connections between some of these land extreme events and the coastal ocean, even if those weren't there, there are also a lot of ways, as you've already started to articulate here, how climate impacts are creating similar kinds of extreme events in the ocean that have impacts on the ecosystem and the way that people interact with them. So what can we learn from the lessons that are emerging from the last 2 years in response to these land activities that we could apply to thinking about the way we're managing and interacting with our coastal ocean?
Well, preparedness is always important, and I think that there's nothing like a disaster to get everyone thinking about it. There's definitely things we need to think about, such as sea level rise, that are really going to affect us deeply in the future. I don't know if you've been following what's going on. The city just had a hearing about sea level rise and their new plan and analysis, and it's pretty dire. And I think that we can start to make preparations for sea level rise, and that really affects our coastal economy in a big way. And our fishing community is really tied into our coastal economy, and so there's definitely sort of a feedback there. There's also sort of the work to be done to continue to restore our kelp forests, and I think that would be a natural outcome here. Our urchin fishery really relies on healthy kelp forests because it's the food the urchins eat. And our urchin fishery is in steep decline because the urchin are starving. They're out there. They're very robust little critters that can survive for years without eating much. So if we can bring kelp back, the urchin fishery will revive quite quickly. And I think that there's also, storms. There's storm intensity that's changing with climate change. And being prepared for these storms, making sure we have monitoring systems to keep our boaters safe on the water and to have good advance warning of storms, and to really protect the beach-going population that might not be very informed about storms. We had that wind event, the microburst a few years ago, and that was a terrible event for the people who were out on the beach. And those sorts of climate disturbances are going to become more frequent. So I think more education and awareness are key.
Great. Well, let's thank our panel for this part of the discussion. And we're going to have some time for you to ask questions of everybody, but before I turn things over to Sigrid Wright, I want to ask you 2 more questions that'll help us thinking going forward as well. Next slide. What is the biggest takeaway from today's discussion that you all have? This will help us think about projects that we all, as individuals, need to be working on, and collectively. Lack of complacency, always looking for ways to adapt. Really good ideas. Okay, those are really helpful. And then here's the last one, the next slide. Keep striving, adapt and wait. Can I have the next slide? It's a perfect follow-on to those 2. What would be a great topic for our next community discussion? Because this isn't the last conversation we want to have. There's still lots of opportunities to learn and innovate. So if you have ideas for what would be a good focal topic for upcoming discussions, it would be great to have them. And then I'll turn things over to Sigrid Wright, and then we'll have an opportunity for you to have your written questions go directly to the panelists and speakers. Yeah, it's good to see the focus on mitigating. We've been talking about how do we adapt, and obviously one of the ways that reduces the need for adaptation is to reduce the problem and magnitude of the problem in the first place. And so a big part of this has to be a focus on thinking about how do we mitigate these climate drivers of these new events. Sea level rise getting a double vote here. This is great. Okay. Well, this has been very helpful, and we're right on time, so I'm going to turn things over now to Sigrid Wright, head of the Community Environmental Council, for some comments, and then we'll open things up for direct questions to all of the panelists and speakers. Thank you.
Well, good afternoon. I want to thank our panelists and Steve there. That was really illuminating. So here we are a couple of years later, and I think we can all agree that the Thomas Fire and the Montecito debris flow caused enormous personal loss to this community. The loss of 23 lives, the loss of property, health impacts for many people.
and for thousands of businesses and self-employed workers' loss of income. It was also, for me, the turning point in the public discussion about our changing climate. I have personally worked on climate change for over 25 years, and it took these two very painful illustrations to highlight for us how the changing climate is playing out on the Central Coast. In terms of the cycles now and the kind of increasingly more pronounced patterns of greater heat, extreme drought, year-round fire seasons, and then punctuated by more intense storms. And we've even had to create new language to capture this type of precipitation. Dr. Selko just mentioned, microbursts, rain bombs, atmospheric rivers. This is new language for us. Today, we're clearly really wrestling with how these stressors and then other stressors are all kind of interplaying with each other, and what's our role and what's the role of nature. And maybe it's today's date, but I've been particularly reflective this week about the comparisons between the unfolding disaster of climate change and the disasters that we've just been through, and the 50th anniversary of another catastrophic disaster in our region's history, which was the oil spill of January 28th, 1969, the largest oil spill in the nation at that time. Then, as now, people who would not have considered themselves activists were moved by the enormity of the disaster and its impact on public safety, public health, and natural systems. And I'm reminded that a year after that oil spill, on January 28th, there was a large public convening, not unlike this one, organized by a group called the January 28th Committee, to reflect on the lessons learned, the science, and the action moving forward. So we're really mirroring history here today. At that time, the ecology movement was just emerging. The awareness that everything is connected was really, at least in the kind of modern sense of the word, was really just a kind of an emerging thought. Today, we have much more sophisticated tools to understand that healthy, functioning ecosystems are like healthy, functioning human bodies. It was even the map that Dr. Brooks put up there with the aerial maps even looked to me like a map of blocked arteries. We talk now very much, when we're talking about creek and ocean health, about oxygen levels, acidity levels, toxicity levels, just a lot of mirroring language. And I've come to think of environmental scientists almost like MDs, who are sending us a very clear message that without environmental health, we cannot thrive. I also want to share with you another observation about the importance of these types of conversations. Recently, CEC, Community Environmental Council, began to hold a series of roundtables with about 120 community leaders to explore those different climate threats that I just mentioned and the way in which they interact with each other and compound each other. And at the first of these discussions, which focused on wildfire and smoke, former City of Santa Barbara Fire Chief Pat McElroy and current Fire Chief from Montecito, Kevin Taylor, made these comments, that these convenings are a big step in recognizing issues in which everyone has to get out of their silos and talk to each other in advance of an incident instead of post-incident. In other words, we don't want to be meeting each other in the middle of one of these incidences. By talking with and understanding each other's point of view, it will help inform the decisions that disaster managers make in real time. And that once you get to know someone, you have respectful conversation, it becomes very difficult to dismiss their concerns. So I found that very inspiring, Pat and Kevin, and I wanted to bring that forward into this room. So I'm very grateful to the panelists and to the organizing team and to all of you for spending a beautiful Sunday afternoon in here, sharing and learning from one another. And in the words of Mo Gomez, I just want to remind us that recovery takes time. So thank you all.
All right, thanks everyone. A lot to think about in this last 90 minutes. So we're going to rearrange the deck chairs. bring everybody back up. If you have questions, I hope you're writing them down, and we have Justin and Tristan will pick up the questions. So give these people some tough things to talk with us about, okay?
I know.
Let's make these hard. Okay, our first question. What forest management is planned for the future? Who would like to volunteer for that? I know Sarah's thought a lot about that. And
Well, as some of you may know, the community is just beginning the public phase of thinking about the new version of the Community Wildland Protection Plan. Community Wildfire Protection Plan. And so that's part of the process through which the community partners with the agencies who mostly are the ones who end up having to do the fuels treatments because it's mostly on public lands. And our defensible space, of course, is on our own private lands, and there's a little bit of other land, but a lot of it's on the federal lands. And so that's one way that our community can partner with the federal agencies to make sure that we're getting input into, but also making sure that those serve our communities really well. And so that's how I would, I don't know exactly what's planned, but that's how our community can interface with that process. Now that the microphone is working, I said that we've just begun the new round of public conversation about a community wildfire protection plan, and that's the way the communities formally can partner with and produce documents to help the Forest Service, who's going to be the ones mostly doing any fields management that happens on our landscape. And so I'd encourage folks to get involved in that conversation if you're interested in fields treatments for wildfire protection.
okay, we have multiple questions around debris basins, and in particular, asking about new innovations and also the likelihood of taking advantage of successful new models like the Gobernador, I think that's how it's, Gobernador Canyon debris basin was implemented. And so, Tom, would you like to say something about that?
Sure. As I mentioned, the Gobernador debris basin was actually done, I think, about 10 years ago. It was well in advance. And the idea was that a typical debris basin has a dam on the creek and a small pipe that has the outlet. And what happens is that outlet plugs. And so we trap everything, including the stuff that we may not want to trap. What we're really after are the rocks. And if Mo had his way, the vegetation too, which, by the way, is something we're looking at. We're trying to come up with a way to stop those big logs because they float, and so it's challenging at debris basin. We are taking the Gobernador model and have grant applications in with FEMA right now to modify 3 basins in Montecito, the Cold Springs, San Isidro, and Romero, which would do a number of things. One, that it opens up the debris basin for fish passage, which we're mandated to do. And at the same time, it doesn't trap the fine grain material, and it allows us to retain the rocks, which are what we really want to stop. Rocks, boulders, large rocks, medium-sized rocks. and let the finer grain material go on through the system, and then that lets it get to the beach naturally. So we're taking that and moving that way with those with that approach. We're actually going to be applying that to other bays, like below the Cave Fire in Goleta, San Antonio debris basin. We've had to clean that basin out several times, not one, all seven. We shouldn't have to be doing that. We should be spending the taxpayer money to be doing that. So we're going to apply these techniques to those debris basins over time, and we have some grant funding that we're chasing to do that. And then lastly, I would just say on the new debris basin that we're proposing uses the same technique. We're not building a dam. We're in a sense widening an area that would allow the rocks. Rocks have to have fast-moving water for it to move. When you slow that water down, the rocks will drop off first. The sand will keep moving, and the sediment will keep moving through. And at the same time, we're hopefully going to buy 8 people out of the farms at the same time. So that's a good thing as well as talking about.
Great. Okay, a couple of questions for Brandon. Can you reiterate again how much debris has been dumped at Goleta Beach? And if human DNA levels were actually below the published standards, why did the beach stay closed so long?
Good question. So it was 41,000 cubic yards of material that was deposited at the beach. As I said, it's not unlike a large beach nourishment project, as I saw from the records before. There were other beach nourishment projects about 40,000 cubic yards. I think 20 or 2,000 truckloads of materials. Usually the beach nourishment projects, the materials derived from when the beach slew. So you're kind of killing 2 birds with 1 stone. You're clearing it out for flood control benefit, and you're depositing at the beach for beach nourishment. And then the second part of the question about why there was very low to no human marker detection despite beach closure. Beach closure decisions are made according to Assembly Bill 411, which is a legislative program where when fecal indicator bacteria levels get above state standards, beach closure decision has to be made by a county public health official. Those indicator bacteria measure all bacteria from the environment. Bacteria from the environment are human fecal origin, non-human fecal origin, and environmental non-fecal origin. So what we were able to test for is just honing in on the human fecal bacteria. It's broader than just bacteria, like protozoan viruses. So we have a marker of that. We tested the marker. We tested that marker all over. I've been in Boston, applying it in Boston. And I'm glad we're not swimming in the Charles River, and I'm glad my kids and I swim in Santa Barbara's beaches because they are so low in human fecal marker. They're not zero because in an urban beach setting, they are, there's a background, and we don't have to talk about these things, but there's bather shedding. And the level that we saw at Goleta Beach was comparable to what we saw at Santa Barbara beaches in summers during recreation periods from bather shedding. So unfortunately, we can't use that information to make beach closure decisions. We have to use the indicator bacteria. So what we were able to do, what the county public health was able to do based on our information, when the concentrations rebounded, instead of saying like during the first 6 months where they said the beach is closed, when we saw that chart of indicator bacteria, those episodic blips, when those happened, they were instead able to say, we're just going to post a warning. We're going to advise people not to swim based on indicator bacteria levels, but we're not going to outright close the beach. So that was a change in policy that county public health was able to run with based on the study results.
Hey, Steve, I think I'd also have a perspective to weigh in on that, because I think the bacterial contamination of the ocean after these activities is one of the most, the bacterial contamination at the beaches is one of the most common kind of concerns and questions. And first, I've known Brandon a long time, and the work that he's done and his collaborators at UCSB, I highly respect, and I think that information is really useful. I have a slightly different perspective about maybe about the significance of fecal bacterial contamination even when it's not human. And human contamination has been a focus because I believe that there is the highest sort of correlation of pathogens or human illness associated with human as opposed to other sources. But I would venture to say that that's not to say that the other sources don't entirely matter. And there is kind of, we do get caught up in this, I don't know, this argument sometimes that, well, it's dogs or it's cows or it's birds, and that's nature, and therefore it doesn't matter. Well, when it rains and we have a big storm and bacteria washes out in the ocean and you get all of those sources, I think people understand that the ocean water quality suffers for a period of time, and we say about 72 hours later, it's usually the levels fall back and it's fine. When we deposit debris onto beaches for a period of weeks, 6 weeks, 2 months, those elevated bacterial concentrations persist for a much longer period of time, and that's not natural. Now, do we care if we're swimming in water that's contaminated with animal fecal contamination? I would venture to say that most people do. Most people do want to know, you know, even if it's from birds or it's from black bears or whatever it is, it still matters, and the state standards are what they are because they're not based on the human fraction, they're based on the total. And at the very least, I think being informed, which is what I think the county moved forward with this last time, is important, because I think people want to make informed decisions when they're recreating.
Yeah, very good points. And yeah, feel free, anybody that wants to add some additional comments, just raise your hand on these things. So the next one I have is, what is the importance of future land use planning and development in high-risk areas to adapt to the new normal of climate change?
Well, I'll take
Volunteers?
I think the one thing that comes out of a disaster like the 1/9 debris flow is a lot of the houses that were severely impacted were typically older. We've seen a lot of examples of newer construction in the debris flow path that survived. Actually, some examples of a house right on San Isidro Creek, and the residents slept through the whole thing because it was constructed in 2006 and met our floodplain management criteria, which is elevation. A lot of these homes that now are going to be coming in to be rebuilt, and I don't know how many will be rebuilt, how fast, and to what extent they all will be rebuilt. But they do have to conform with new floodplain standards, which requires elevation, certainly, which is a big help. And then also what I'd like to see, although it's often difficult, is there are structural construction techniques that when you're in a high hazard area, you can implement that would make a house be able to sustain certainly a flood and to maybe a lesser but still insignificant withstand the debris flow. And so we'll see as these houses come back in, they're going to be built with more modern construction techniques, and they certainly will be elevated in an area where they'll be much better positioned to be able to sustain a future flood or even debris flow. I think I would just add on that, in a perfect world, if you look in, say, Goleta, you see that during developing later than other areas, like if you look at Mission Creek in downtown Santa Barbara or parts of Montecito, there are development and houses that are directly adjacent stream corridors. In Goleta, you see these large open areas of open space that are in the stream corridor, and then that didn't happen by accident. That was a very direct planning decision that was made by the county, and we can see that works out really well. But that's because Goleta grew up at a time where you could start with a clean slate and could make those decisions much easier than what you have now.
Mm-hmm. Mm-hmm.
Yeah, I would echo what Tom just said.
development, to me, sort of is a ratchet. It only goes one way. We very rarely undevelop things.
Yeah, for sure do this
And
one.
of course,
This
as
one,
soon as
this
we allow
one's
development, there's an obligation to protect
people already said.
to protect people's homes. And so I think we need to put a lot more thought into where we allow development and what types of development we allow to occur in those places where we do allow. Because we're not going to just show up one day and say, well, gee, we made a mistake 50 years ago, all this stuff has to go. What's going to happen is that stuff is eventually, especially along the coast, it's going to be inundated as sea level rises. It's going to be subject to more frequent and intense winter storms, sometimes associated with El Niños, and we're going to see more and more unfortunate sort of natural impacts. And we can prevent a lot of that, as Tom just said, through better, more creative, and more forward-thinking decisions, policy decisions about where we develop and what types of development we allow.
So I'm going to just complete the thought there, which is we're clearly having conversations about development into high-risk, high-fire areas, and then, as you just mentioned, we're going to be squeezed, particularly in the Santa Barbara region with the sea level rise. So we're going to need to be making some tough decisions about where that's probably going to lead to more infill, and then as increasing height. Where are we going to be placing houses, and how are we going to develop with a little strip? Because we're not growing, we're getting squeezed.
Great. Okay, let's move to the salt end of things. Kim, what, with respect to kelp forests, what are the best approaches for restoration?
I should start by saying I'm not an expert on kelp forest restoration, but there's a lot of different groups along California tackling this. The Bay Foundation, working in Santa Monica Bay. There's basically ways to set up structures on which kelp can grow and to kind of outplant the kelp. And there's also sort of a more ecosystem-based approach of removing some of the purple urchins that are overpopulated. So the fishery species we have for uni is a red sea urchin. The urchin barrens that are created are from purple urchin. And in the past, historically, there have been programs that have allowed people to go out and smash those urchins. There's debate whether that actually releases their eggs and sperm and causes them to reproduce more. A really fascinating and exciting option is to start ranching purple urchins. They are not a fishery species because they're about a third the size of the red urchin, and their gonads, the roe that people eat, are about a third the size. But you can scoop them up, put them in bags, throw in some kelp, and feed them for 6 weeks, and that roe fattens up to the point where it's maybe 2/3 the size of the red urchin. You can't get as high a price, but they're so abundant. And that turns a restoration project into something that actually has an economic driver behind it. And I think that that's a really compelling possibility for our coastline, economic opportunity for our fishing community. And Stephanie Mutz, our famous urchin diver who was featured in a film on Friday and Saturday at the film festival, has started doing this. So she's working with the abalone farm to bring urchin to the abalone farm and experiment with bringing them to market, and it's going quite well. But obviously we need to scale that way up.
Thank you. And okay, so next to last question. Are there concerns and is there evidence of impacts of the large amount of fire retardant that has been used both to prevent and to put out fires on a variety of the ecosystems, groundwater basins, ocean, things like that?
I can speak to the water quality risk. My practice is built upon water quality research across California, and this is a chemistry issue. This is not a microbial, so pick up my microbial hat. Put on my chemistry, chemical engineering hat, and we do a
we see concentrations of heavy metals or trace metals jump up, usually associated with geology. We see nitrate and nutrients increase as a result of the ash, organic material. We look at also the effects of burnt infrastructure on water quality, like HDPE and PVC pipes that contribute to organic compounds that are carcinogens. So you see that sometimes building materials that are burned can release copper from copper-coated woods and dioxin from the asphaltic and other building materials. So we see that, but with respect to retardant, we don't see, I haven't seen any impact there. No, I'm talking about the kind that we drop from planes. I don't think that they're, you probably hear about in the news more now more than ever, these forever chemicals, right? PFAS, PFAS chemicals. And you don't see that from what I've seen in nuclear fire retardant. That's in this aqueous film forming foam that is applied, for example, at DoD bases and airports to quickly, tank farms, to quickly put out fires that are putting a lot of people at risk in a dense setting. That is a completely different story. And there are health concerns about that. There's concerns about what is an effective alternative to that, but that's not used for wildland firefighting, in my experience. So with respect to the retardants that I've seen, the closest I've seen to a water quality impact from that is we tested a foam in the recent fires in Ventura County, or we tested a retardant in recent fires, Woolsey Fire in Ventura County, and we had higher selenium content, which is also present in natural geology, but it was just a little bit higher in stormwater following that. But otherwise, it was nothing. So, and the selenium wasn't a public, it wasn't a human health issue, it's more of an ecological health issue. So I don't think that we have things to worry about from a human health perspective in the post-fire water quality. Now, ash, inhalation, breathing, asthma causing, so that's a totally different story that I'm not really speaking to.
Steve, I hate to pick on Brandon all the time. I don't know why. I largely agree with what he said, but I do believe that I'm familiar with one incident, at least locally, where retardants may have had an in-stream impact on fish, steelhead specifically. And there was actually a biologist, I think it was Dr. Scott Cooper at UCSB. I think that it's ammonium phosphate is one of the active ingredients in PhosCheck, and the ammonium in streams can be toxic. It dissipates rapidly. It oxidizes into forms of nitrogen that are not toxic. So I would speculate that the risk to streams post application of these chemicals, certainly if you drop it in the water, I would imagine that there could be an impact there. If there's a storm immediately following application, then you're probably also transporting some of those chemicals to a stream where there may be potential, but that's slightly different than I think what Brandon was speaking to.
Great. Okay, so let's finish this off with a question about individual action that aligns with the comments that a lot of people had in terms of the responses from the audience to the online questions. So what do we as individuals do outside of buying emergency kits, recycling, and using less waste to actually promote community resilience? And so maybe we could just go right down the aisle, and if each of you could just give one individual action that would have a positive effect, that would be great. It'd be a good way to end it.
So I get to go first?
Sure. You can battle it out with Sigrid.
Well, I think probably the one thing that's really important, and I think we're getting, let me just ask for people that's left, how many people are registered for Aware and Prepare on your cell phone? That is awesome. For those who aren't, you should be ashamed of yourself. And your job next is to go register. Because and make no mistake, there's room for improvement on communication from the county, the state, federal, to the individuals. And I think it's improving. There's certainly room for improvement, but those, the cell phone is here to stay, and that's our way of, how many people no longer have a landline? I don't, and a lot of people too. So that's our way of getting a hold of you, and so there's one thing if you haven't done it is make sure that people can get a hold of you and you can get the information that you need.
I was actually going to say the same thing. No, I do think, back to, there's only so much that you can rely on our local agencies to protect you, and at the end of the day, I think, I've been evacuated myself and my family, how many times now? 8, 9 times, I think, over the last few years, and it's frustrating, and it can be disruptive, and it's scary, but it's also, it's out of our control, and I think, please heed those warnings. And the only other thing I would say, our board, we had a discussion yesterday about climate change, and sometimes I hate to even bring up the words climate change, climate resilience, because it's so big, it doesn't feel like we can actually do anything about it, and it can be discouraging. And so, though, we still do the work that we do locally because that's what we can do, and to the extent that people can do what you can to, reduce your carbon footprint, protect our local watersheds, all of that still matters.
I would just add, as a citizen of this town, to get to know your neighbors and make sure that you can rely on them and that you have that network locally on the ground, because when the electricity goes out and cell lines are overwhelmed, you're going to go out on the street and need to talk with everyone. And if you've known them and you understand what you can ask of who on your street, it makes a big difference. And I'd also add that when the 101 was closed after the debris flow, and we weren't getting much food on our shelves, our fishermen were still bringing in fish, and our Saturday Fishermen's Market got a big uptick in visitation because, you can also rely on a fishing boat to take you down to Ventura if the 101 is closed, or come get some seafood locally at our Saturday Fishermen's Market.
A lot of what I do involves evaluating the impacts from stormwater to the coastal environment. So I think our behaviors has a lot of control over that. When we drop trash, you see about this in the commercials all the time. Trash is one of the major issues of concern today. It seems like such a basic thing, but you see all these trash islands out in the Pacific, micro trash, microplastics that are out there. So pick up trash, try to be a habit of picking up trash, not dropping trash, picking up dog waste, it all gets flushed down there. Minimizing your pesticide use. Pesticide is the #1 cause of fish toxicity usually in dry and wet weather. So think about that, because everything you apply in your home environment is going to be flushed out in a wet weather event. And then your pharmaceutical and personal care product use. That's not really a stormwater issue, but when you flush it down the toilet, when you urinate and defecate into the toilet, it makes it to the treatment plant, and a lot of that stuff, it makes it right through the treatment plant. All those chemicals we put into our bodies. And then that has unknown effects. We don't even have what for most of those chemicals. And they go right into the ocean. So think about what they might be doing to the environment.
I'd go back to continue to tell this story, because that's the way that we maintain our own community's history. People move in and they didn't experience it, and so we need to tell the story as painful as it is. And then it's also the way that our story can affect other communities who face, as I said, the same risks that we face. So keep coming to these things and telling these stories and talking to your neighbors about it, even though it's painful.
Yeah, I think those of us at this end of the line deserve extra credit, because most of the
You can just say ditto.
Yeah, part of what I'll say echoes everyone else, but I guess my message would be something that my father always told me: if you don't vote, you can't complain. And so we all have a responsibility to take part in this process. And
that means being engaged at both the local level and a state level and a national level. So if you're concerned about these issues, do something about it. We can't Monday morning quarterback our way through this. The other thing I would say, hopefully to empower you all, is that even small changes can have big effects, right? So some of the issues that you just heard about, just changing our sort of personal lifestyles, can make a huge impact if you think that everybody in Santa Barbara is making those same types of efforts, right? So we're all in the boat together. We're either going to float or we're going to sink as well. And we all need to sort of get together, get involved, and sort of take a stand.
So my comment or recommendation would be to not only get engaged, as Sarah and Andy were saying, but support groups that you know are doing a good job. Support the Community Environmental Council, who is doing a great job of organizing events like this, as well as the Museum of Natural History. Support groups like Channel Keeper that are doing a good fight to keep our water quality as pristine as it can be, and our groups as well that are doing good work to help improve the habitat. So, thank you.
Mm-hmm.
Here's my payment. So we followed a really interesting thread here, starting with very personal action, signing up for disaster aware, prepare, and notifications, and personal action, and I think it's widening out here towards the end. So I'm going to give you kind of a geeky but extremely important response, and that is all of the things that we've talked about today require planning, right? So the county is going through planning regarding its debris basins, hazard mitigation planning. We will soon go through climate action planning. The city is releasing their strategies for sea level rise planning. We have community-based plans as well, food action plan, which looks at the food system, and all of these things are only as strong as those of us who show up for those conversations. There's no shortage of opportunity, and so I'm gonna end with the importance of engaging in planning.
Great way to end. Thank you. I'm going to turn things back over to Luke now.
All right, thank you, Steve. Thank you. What a body of expertise. So thank you, folks, for staying with us this afternoon. Stephanie has baked cookies for us, which are outside. I need you folks to stay here because KEYT and the news press now want to go after you. I want to thank Joe. I want to thank Olivia. And remember, you can look at this on our websites in another couple of weeks. And I've just committed the organizing institutions without talking to them that we will do some kind of a summary of this because we want to get what we've talked about and some of the good suggestions out to people that couldn't or wouldn't be here today. And I mean, we'll get it out to our elected officials, to all of our agencies at the county and at the city level. So there were just a lot of people that we couldn't put on this panel or that couldn't be with us. So we're going to commit to doing everything we can to get the message out to them. So thank you, and we'll see you again at our next community conversation.